Alright, hello and welcome back. We are talking about surface areas of spheres. We're in chapter 11, section 7. Okay, on a sphere, you have a center point, and from that center to the outside is the radius. A chord would just cut through the sphere from one side of the sphere to the other. And if the chord includes the center, then that is the diameter of the sphere. Now, if you take a plane and you slice through a sphere, that will result in a circle. Now, if that circle goes through the center of the sphere, then it creates what's called the great circle, okay, and splits the sphere into two hemispheres. All right. The surface area of a sphere is basically 4 times the area of a circle. So 4 pi r squared. If we want to find the surface area of this, pretty easy. Surface area is 4 times pi times r radius squared. So 64 times 4. And that is 256 pi, or approximately 804.25 inches squared. All right, now if we know the circumference, we would have to first find the radius. Remember, circumference is 2 pi r. Okay, so if 2 pi r is equal to 12 pi, well, then we can divide each side of this by pi, cancel that out, divide that by pi, divide it by 2, divide that by 2, cancel out the 2, and then we are left with 6. So the radius here is 6. All right, and then we go to surface area, which is 4 times pi, 6 squared, and calculate that puppy. We get 144 pi, or approximately 452.39, and this is in feet squared. All right. If I know the surface area and I want to find the diameter, well, I'm going to use my formula again. I know that surface area is 4 pi r squared, and I know that that is 20.25 pi. All right, we're going to do a similar process as we did before. Divide each side by pi. That'll cancel that out. Cha-ching, ba-bang. Bing-a-da-dang. All right, divide each side by 4. Divide this by 4. Cancels that out. Then we get r squared is equal to about 5.0625. And then we have to square root that. We get the radius is equal to 2.25. However, they have not asked us what the radius is. They've asked us what the diameter is. So the diameter is 2 times the radius. 2 times r, so that's 2 times 2.25, and that is 4.5 centimeters. Okay, the surface area of a hemisphere. We know that the surface area of a sphere is 4 pi r squared. So logically, the hemisphere would be half of that, right? So we divide that by 2, because sphere divided by 2 gives us a hemisphere. Hemisphere is sphere divided by 2, and that would be a surface area of 2 pi r squared. But wait, you say. This is not open, it's closed. It has a base. So it's not just that, but it's plus a circle, pi r squared. So it's 2 pi r squared plus the base, pi r squared. So 2 pi r squared, we could think of that as the lateral area of the hemisphere plus the base, pi r squared. So you can rewrite this as 3 pi r squared, because we've got 2 of the pi r squareds here and another pi r squared. We've got 3 pi r squareds. All right. Find the curved surface area. So per se, the lateral area. Remember, that's just 2 pi r squared. The surface area, let's call it the lateral area. Lateral area of the hemisphere is 2 pi r squared. All right, so that's 2 pi times 7 squared. So 2 times 49, which is 98 pi. 98 pi, or approximately 307.88 centimeters squared. Find the total surface area. We could either do the whole thing with 3 pi r squared, or you can just add in one circle. So you can do pi r squared and just add that to this, which is 49 pi. Add 49 to that, or we can find the total surface area, say that is 3 pi r squared, and that would be 3 pi times 7 squared, and that gives me 147 pi. So a couple ways that you can do it. Either just add another full circle to this, or recalculate the whole thing, and that is 461.81 centimeters squared. All right, composite figures. All right, here, notice the circle on the inside. The bases of either of these are not included. So I'm going to find the lateral area of the hemisphere and add that to the lateral area of the cone. Okay, and that's the surface area of the composite. Lateral area of the hemisphere, remember, is 2 pi r squared, plus the lateral area of a cone, if you'll remember, is pi r times the slant height. Okay, nicely enough, they gave us the slant height here. We don't have to calculate it, and they gave us the radius. So it's 2 pi times 4 squared plus pi times 4 times 6. And then we add those together, multiply, we get 32, 16 times 2 is 32 pi, plus 4 times 6 is 24 pi, and that gives us 56 pi, or approximately 175.93, and that is in inches squared. All right. Here we have surface areas. We are given a surface area, and we're looking for the surface area of this one. All right, so this is going to be my new. This is going to be my original. Remember that scale factor, we use the letter K for that, is new to original. Okay, so new means 6, to original is 8. All right, now, in order to find this surface area, I'm going to have to square this, because remember, area is always squared. So square that, and then multiply that times 256 pi. All right, now 6 over 8 can also be simplified down to 3/4. 3/4 squared is 9 over 16 times 256 would give me approximately 100 or exactly 144 pi. And that's in inches squared. All right, you purchase a new beach ball with quadruple. That means 4 times. 4 times the surface area of your old beach ball. compare the circumference of your new beach ball to the circumference of your old beach ball. Alright, so beach ball 1, okay, and beach ball 2. Okay, so the surface area is 4 times. Okay, so surface area, let's pretend like this is 4 and this is 1, right? Then my scale factor here would be 4 to 1, but that is the scale factor squared, right? Because that's surface area. So in order to compare the circumference, I'd have to find the scale factor and square root these. And so the scale factor there would be 2 to 1. Okay, so that means the circumference of the second one is twice circumference new is 2 times circumference original. Alright, because it's 2 to 1. There you go, ladies and gentlemen. Lots of fun for everyone. Check in again next time for another fun lesson.